All right, let's take a look at today's lesson. So today we're going to be working on arithmetic sequences in series. This should be a bit of a review. We did some of this last year. So let's take a look at the formulas that we will need to be able to do this. So let's remind ourselves, an arithmetic sequence is one where we add the same number over and over again, or we subtract the same number over and over again to get the next term. So that's how we can tell if it's arithmetic, if it's the difference in each of the terms is the same number, either a positive or negative number. So the nth term, if you recall, this is just a fancy word for the formula used to generate our sequence. Of course, this is explicit, the explicit formula. We talked about those things the other day. What we want, our default, is explicit. Normally, we would prefer an explicit formula versus a recursive. So this is the explicit formula. So to get the nth term, we would take this is our first term. A is our first term. N is the term number. And D is the common difference. So those are the parts of that formula. So you would need that information to be able to write the formula. Now let's say we want to add up the first particular number, say the first 70 terms of an arithmetic sequence. We really have a choice. We have two different formulas that we could choose from. These are both summation formulas, partial sums. And it really depends on the information that we're given as to which one would be most helpful. So this a sub n is the last term being added. It's the actual term, whatever the term is. Let's say 7 is the last term, then you'd put a 7 there. N is the number of terms being added. It'd be good if I could spell being added. And A, again, is the first term. You know, A here and there, it's the first term. N is, you know, wherever N is, in the summation formula, it's talking about the number of terms to add. And D is our common difference. Okay. All right, so N is the number of terms. There's two different N's. There's another one there. So that kind of labels all of those variables to let you know what they stand for. When we're working with arithmetic sequences, sometimes to get the common difference isn't as easy as other times. Let's say if they give us the first and the second term, well, that's easy. Then we just subtract those and we get the common difference. But let's say they gave us the, I don't know, the 8th and the 12th term or something like that. That's going to be a little bit harder. So I have a helpful formula. This is a helpful formula for finding D. What are we going to do? We're going to do the next term. So D is going to equal the next term minus the previous term divided by the difference in the term numbers. Okay, so for example, let's say we know that a sub 8 is 14 and a sub 12 is 24. In other words, the 8th term is 14 and the 12th term is 24. Well, it's not really, readily apparent what the common difference is because those terms are so far apart from each other. So we could use this handy little formula, if you want to remember it. You do the last term that you have, which is the 12th one, so 24 minus the previous term that we have, which is 14, divided by the difference in the term numbers, 12 minus 8, and that would actually give us, once we do the arithmetic, that would give us our common difference. So that's kind of a handy little formula right there. I'm just going to kind of circle it. This is kind of a handy little formula. If you want to remember that to be able to find the common difference regardless of which terms they give you. The last thing that I want to talk about is this first differences. So if the first differences are the same, the sequence is arithmetic. That's kind of what we're talking about, right? So if I, let's just an example. So we've got 2, 4, 6, 8, and so forth. So if I take the difference between 4 and 2, and the difference between 6 and 4, and the difference between 8 and 6, it's all 2. That means this is arithmetic. That's what that means. The first differences, that would be the first differences are all the same. If the first differences are not the same, but the second differences are, then what we have is a sequence that is quadratic. It's a quadratic sequence, and this is the formula that we would use, where A would equal half times the second difference. Now, we're not going to be, I know you're going to be so upset, we're not going to be doing there are some really fun ones of these, but we will not be writing nth terms for a full 3-termed quadratic like this. I know you wish we could, maybe another time, but we just really don't have time to work through this. We will not be writing nth terms, in other words, formulas, and that's the nth term formula for quadratic one. Nth terms for a full 3-termed quadratic. That would require, and working these are so fun. Like we could do like a system of 3 equations and 3 variables. Oh, it'd be delightful. I know we just will not have time, but I wanted you to be aware that if one of those comes up, a more simple one, if the second difference is the same, then that's going to be a quadratic sequence. All right, so let's kind of jump into our work. Let's do our first example. If the 11th term of an arithmetic sequence is 52 and the 19th term is 92, they want us to find the 1000th term. Okay, well, we need to write a formula for it first. So if we're looking for terms, let's just write sometimes students get confused on, well, what formula do I use? How do I know what formula do I use? If you're looking for specific terms, then you need to write the A sub n formula. So you need to write A sub n. That's the one you need to use if you're looking for a specific term. Okay, so we're looking for the 1000th term, so we need to write our formula, but we need the common difference first. So let's use that handy little formula I was talking to you about just a minute ago. Let's see, the 11th term and the 19th term. So let's put the 19th term first. So 92 minus 52 over, and then we've got 19 minus 11. So we do our arithmetic, we get 40 over 8 or 5. So our common difference is 5. Okay, well, we don't have our first term either, so we need to find the first term. So let me write out here to the side and remind you. So it's A sub n, our general formula. A sub n is A plus n minus 1 times d. That's just the basic formula for arithmetic sequences. Okay, so we need to find the first term. So A sub 1 is the one we're looking for. We don't know what it is, but we can use the other terms. We can basically plug in the other terms to figure it out. What if in this little spot right here, what if instead of putting the first term, I put, say, the 11th term in? Let's just put the 52 in there. This is just one way to find the first term. There are other ways. And then I'm going to take away, let's see, that's the 11th, and we're actually not using this formula. This is a kind of a common sense way to do it. So we take the 52, which is the 11th one, and so there are 10 terms that we want to get rid of. We have the 11th term, but we want to get rid of 10 terms, and the terms are, they all have a common difference of 5, and that's going to basically take me back to the first term. So I'm going to say that again. To get the first term, you take one of the terms you have. In this case, I took 52, and I want to take away, so I'm trying to take away all the terms between the first term and the 11th term. So I want to take, I take away 10 terms, right? I need to get, since I have 11 terms, I take away 10 terms and I get the first term. And I would multiply the number of terms I take away by the common difference. And when I do that, that's going to take me back to my first term, which is a 2. Okay, so that's one way to do it. So now let's write our formula. A sub n equals a 2 plus n minus 1 times 5. That's our a sub n formula. Okay, great. We want a sub 1000. So a sub 1000 is 2 plus 1000 minus 1 times 5. And of course, with numbers that large, you would totally have a calculator. So a sub 1000 is going to be 4,997. Okay, so that's just kind of a reminder on how that works. All right, so let's take a look at our other problems on the next page. So our next example is giving us 2 random terms, the 8th term and the 20th term, and our first task is to find the first term and the common difference. We're going to use the same scenario we did before. I'm going to use my fancy formula for common difference. So I'm going to do let's see, the 20th term is 39 minus the 8th term is 75. So I would do, 20 minus 8. So we would do our arithmetic, negative 36 over 12, which reduces to negative 3. So my common difference is negative 3. Okay, so let's work on the first term. So on the first term, I'm taking 75. I just chose that one at random, 75. And I'm going to take away, let's see, 75 is the 8th term, so I need to take away 7 terms whose common difference is negative 3. That's going to basically, it's like rewinding it, if you will. It's going to take me back to the first term. And in this case, the first term is 96. Okay, great. What we're going to do next is we're going to write 2 different kinds of formulas. We're going to write a recursive formula, and we're going to write the explicit or nth term formula. This would be the explicit formula. We're going to write both so you can see both of them. So the recursive formula, to write the recursive formula, the first thing that you would need to do is to, you have to give them something. Like at least the first term. You have to write at least the first term. Because if you recall, with a recursive formula, you can't get the second term unless you know the first term. And you can't get the third term unless you know the second term. So a recursive formula has some limitations. Like if I wanted the 1000th term on a recursive formula, I would have to find all 999 terms before I could get to the 1000th term. So not that helpful for us in some ways. In other ways, it's very helpful. So what do? The parts of a recursive formula, we have to list a term, the actual term. So a sub 1 is 96. Then, we'll put a comma. Then we list the formula. How am I going to get all of the next terms? Well, we just figured out that I would subtract 3 every time. Right? We'd subtract 3 every time. So I take the previous term, which is a sub n minus 1, and I subtract 3. The a sub n minus 1, that means previous term. Okay, that's what that means. That means previous term. So I take my previous term, so I would take 96, and I would subtract 3 from it, and that would give me a 93, and then I could keep going. So this would be the recursive formula for this sequence. Okay. And we did some recursive formulas last time, so hopefully that still makes sense. The next one, we're going to do the nth term formula. So that's the explicit one. So that's the a sub n equals, it's the formula that we're given. We put the first term down, which is 96, plus n minus 1 times negative 3. So I kind of want to clean it up and make it look, a little bit better than that. So I'm going to distribute the negative 3 to both of these. So that will give me negative 3n plus 3. And then just simply, cleaning it up, that gives me, what would that give me? It will give me 99 minus 3n, and that's my nth term formula. Okay, so there we go. So we just practice writing two different kinds of formula for the same sequence. Okay, so let's do this next one. Find a formula for the following sequence. Let's see. So this, I'm glad this popped up. So when I was doing the notes previously, I actually changed this problem. And so what I want you to do is I want you to change this problem for me. So just on your OneNote, just go in and change it. And instead, I want you to cross this part out. And I want you to say, find the sum. All right, and I want you to cross these out. That one would have been so fun. That's one of those crazy quadratic ones. I know you wish I was doing that one, but I decided to not do that one, and we'll do this one instead. So we're going to find the sum, and so that would be 60 plus 64 plus 68 plus 72 plus ... plus 120. Okay, so that's what we're going to be doing. We're going to find the sum. And if they say sum, we've got to use one of the summation formulas. And so our little clue back here. So let's look at this little clue over here. So if we're looking for a specific term, looking for some specific terms, we use the a sub n formula. Okay? If we are looking for the sum, we use an s sub n formula. Now it may be that we don't have enough information for the s sub n formula, so let's start filling it out. So s sub n equals, now the n is the number of terms. I already know I've got a problem. I don't know how many terms I have. So since I don't know how many terms I have, so our formula is s sub n equals, let's just write it down, n times a plus a sub n over 2. All right, so let's see what we have so far. We've got our first term. Okay, that's great. And we have our last term, yay. But I don't know how many terms there are. I don't know how many terms there are. So what does that mean? Let's see. That means that I need this one's term number, because that's the last one, and I need its term number to be able to finish this formula. So instead of just using the sum formula, I'm actually going to have to gotta figure out what term number that is. So I'm going to have to use the regular old a sub n, like the term one. So let's do that. So I've got a sub n equals 60, that's my first term, plus n minus 1 times my common difference of 4. All right, so what do we want? We want the term number for the 120. So 120 is the term, 60 plus, and I need the n. I don't know that. I need the term, that's the term number, right? So now I just need to solve this equation for n, and then I will be able to finish that summation equation up above. Okay, so we started with the summation equation because that's what they were asking for, but we needed to make a little detour because we don't have all the information that we need. So let's see, we've got 120 is 60 plus, let's see, 4 times n and negative 4. Okay, so combining like terms, I get 4n is 64, and then dividing, I get n is 16. Okay, there we go. So now we have all the information that we need. So let's rewrite this summation formula. It's basically s sub 16 equals 16 times 60 plus 120 divided by 2. So we use our calculator to do all that number crunching for us, and then we come out with the sum of those is 1,440. Okay, so that's an example where we're looking for the sum, and we had to take a little detour so we could find more information out. All right, our very last one. How many terms of the arithmetic sequence must be added to get 572? What do we have? Let's see, this is the sum. That's what the sum is. Okay, that's okay. And though if I take a look at this, my common difference is 2. So that's information I have. Let's see, how many terms? So I need to apparently use a summation formula. I don't know the last term. This formula right here needs the last term. Okay, so let's try the other summation formula. Maybe that will be a little bit easier for us to work with. Let's just try it out. If we don't like it, we can go back to that one that we used before. So I'm just going to write down the formula. So S sub n equals n over 2 times 2a plus n minus 1. And our common difference is the common difference. We'll just write that. That's the form. Okay, so let's see what we have so far. We know the sum is 572. We don't know the n, so let's leave that alone. We know the first term is 5, so that's 2 times 5. Again, we don't know the n, but we do know the common difference is 2. Okay, that looks pretty good. So if we can work through this, we can solve for n. That will, that'll be what we need. All right, so working through this, let's work inside the parentheses first. So 572 equals n over 2 times, let's see, that's 10 plus 2n minus 2. Okay, we got that. So let's continue working inside the parentheses so we can get that cleaned up. So what would that be? That would be 2n plus 8. Okay. What I would do, now there's several ways to solve this. I'm going to be honest, I don't really prefer working with a fraction, so what I would do is I would multiply both sides by 2. So I multiply everything by 2 to get rid of the fraction. That leaves me 1144, and 2 times a half is 1, so n times 2n plus 8. Okay, that makes me, that's good. That makes me happier. So now we distribute the n, so we get 2n squared plus 8n. And I'm going to move over the 1144 equals 0. Big numbers, I'm not really a fan of big numbers, and when I see a common factor that I can divide out, I will. So I'm going to divide out a 2, and then it's 0 over 2 is 0, so it's basically going to leave me with n squared plus 4n minus 572 is 0. Now this does factor. I know the number is fairly large, so I'll show you what the factoring is. It's basically 22 and 26. If you had one this big, you would certainly have a calculator so you could work with the numbers. So that's basically what we would get is x minus 22 and x plus 26 for our factoring. So x would be 22 or x would be negative 26. Well, we don't have any, this one is not possible. This one is not possible because the term numbers, it's not possible because you can't have a negative number of terms. Not possible to have a negative number of terms. That's just not possible. Okay. So that means that it was 22. It took 22 terms to be able to add all that sequence up to get 572. So our answer is 22 terms. All right.